The Strive experience aided in building STEM pathway doors for my students to walk through and explore interests they never knew they had. During my placement at Ridout Lumber, I worked firsthand with each and every department within the company. I calculated square footage and adjusted orders for waste, applying mathematical precision. The cabinet department introduced me to the 2020 design software, which transforms measurements into 3D renderings, offering a visual, scaled depiction of custom designs. I accompanied the team on site to measure spaces for installation using tools like a digital scaler to ensure accuracy. Field visits with sales and installation teams gave me insight into the construction process. These experiences highlighted how builders adapt to economic pressures, balancing quality with cost. I even assisted in a fundraising event for a coworker battling cancer, showcasing the company's camaraderie and resiliency. These experiences inspired hands-on classroom activities such as designing, budgeting, and planning structures, bringing real-world STEM applications to my students. An engineering design process will engage the students in a problem-based learning activity based off of my experiences at Ridout Lumber Company in Cabot, Arkansas. Key goals include fostering an understanding of STEM concepts, enhancing problem-solving and critical thinking skills, and promoting collaboration and effective communication within team environments. Students will leave the program better prepared to pursue STEM academic and career pathways, equipped with a professional mindset, leadership qualities, and a strong foundation in interdisciplinary STEM applications, critical to addressing modern challenges. The program focuses on fostering essential STEM skills and career readiness in construction and project management. Students will gain practical experience and theoretical knowledge to prepare them for STEM careers within the community. Through engaging projects, they will connect classroom learning to real-world scenarios, enhancing engagement and comprehension. These tasks will validate their mastery of both technical and soft skills. The engineering design plan requires active engagement in hands-on, inquiring-based activities, enables the students to use their understanding of energy transfer, kinetic energy, and wave interactions to design and construct a structure. This involves applying theoretical knowledge to practical challenges, a hallmark of critical thinking. Students will design a structure to minimize energy transfer, test its effectiveness, analyze the results, and refine their designs based on data. This iterative process mirrors real-world engineering, requiring them to identify problems, evaluate solutions, and improve their approaches. Tasks such as measuring temperature changes, calculating material quantities, and creating graphs of energy transfer rates push students to analyze data, spot trends, and make informed decisions. This strengthens their ability to evaluate evidence and draw conclusions. Estimating square footage, incorporating attic stock percentages, and comparing materials require students to use quantitative reasoning. Solve these problems develops precision and logical thinking. Group activities such as comparing students and revising structures encourage teamwork. Students must share ideas, defend their choices, and collectively decide on the best strategies, fostering collaborative critical thinking. The lesson simulates real-world challenges faced by professionals in construction and project management, such as material efficiency, energy conservation, and cost effectiveness. Students learn to approach problems with practical constraints, enhancing their problem-solving capacity. By evaluating different materials, paint colors, and designs, students practice weighing the pros and cons of various options, a key aspect of critical thinking and decision-making. Students construct arguments to support claims about energy transfer and the effectiveness of their designs. This encourages them to think critically about their experimental evidence and how it supports their conclusions. By focusing on project management tasks such as material estimation, energy efficiency, and sustainability, they explore roles like project managers, engineers, and environmental experts. Activities like measuring temperature changes, calculating material needs, and analyzing energy transfer data build critical thinking and quantitative reasoning skills. The lesson integrates physics, mathematics, and career exploration, fostering interdisciplinary learning that mirrors STEM collaboration. Students practice teamwork, communication, and data-driven decision-making, preparing them for professional STEM environments. Emphasizing local STEM opportunities and sustainability projects, this lesson particularly benefits underrepresented groups, helping them envision careers in construction and related fields.